We're going to start by just looking at a simple ELISA screening data set. So in this case here, we've done phage display to generate HER2 binders. And we've just uploaded an Excel file with 4 columns that represents 3 different signals to various HER2 peptides and 1 irrelevant control. So what I'm going to try to do here now is to find a set of these single chains that have my desired binding properties, and I want to clone them into a new antibody format. So we're also going to define, let's say, a new bispecific antibody format and use those candidates in that format. All right, so I'm going to switch to, is that decent size there? Do you want to go bigger? To the Bionamic application. And it's a cloud-based system that we actually also offer as an on-prem service. But the kind of default is, and our recommendation is to run this in the cloud. So you access it through your web browser, but it's actually, as I hope you'll see here, a pretty, we've put a lot of effort to making this fast. So the performance is more like a native app. So yeah, just in general, we can go and take a look at all the different items that have been registered, and we can actually see them all in one big list here. So we have plasmids, we have antibodies. We can take a look at any of the antibodies just by clicking them. And we have purification batches and data. So in essence, they're all just items, as I said before, listed in the same system that has this network of relations between each other. So I can go into my analysis tool here and look at this little demo data ELISA that I mentioned. And it's, the data itself is, as I said, very simple, just these 4 columns, the 3 different HER2 peptides and our control. And we can freely add our various types of tables and plots over here to plot, like in this example, one of the HER2 peptide signals versus the irrelevant control, and see that we have a bunch of clones up here that show HER2 binding, but with insignificant binding to the control. Now, these are log scales here, I should say. So I can drag and drag in any of these plots, and as you see, they're all connected. So if I drag down here, I can see the same selection up here and across all our different tables and tools here. But to make this kind of fast, I've already prepped a bunch of thresholds that I know will give me a nice list of 8 or so. So for each of the peptides here, I've set a range that I accept, including a very low binding to the irrelevant protein. So I can see that by clicking apply here, I will select a set of 8 clones here that immediately is displayed over here. Now here I can see things like which library they came from and what antigen. I can also just click one of them, and if I want to dive deeper into this particular clone. So here I can see the VH and the VL sequence with its IMGT classification. I can see if it has any liabilities, which plates in our system it's located in, and in which well. I can also see that from which library in this discovery campaign that this clone was originally picked, and so on. But now to actually say that these are the 8 that I want to build my bispecifics out of, I can go in and just add some annotation to these clones. So I can say that this is my status, let's call them hit, and export my list, the hit annotation for those 8 clones. And this is not a training session, so I'm kind of running through this quickly here. But the nice thing is, by doing that, I can at any time, anywhere, just filter these out by looking for my status and hit criteria. So here are my 8 my eight hits. So our next step is to then define our bispecific format. It's quite an ambitious little schedule I have here today. So we do that in our antibody template tool. So you can see we have a couple of templates registered, including bispecific knob in whole. But I can, so I start by defining what kind of chains I want in my antibody format. I can add any number of chains. We have customers that have very complex antibodies. So here I can also add how many different binders do I want. So in this case, I might want two. I want one just VHL in our traditional mAb position, and here we're also going to add a single chain to the light chain, we can see. So we're also going to add something called a single chain right there. So then I just need to define what's in my chains. So starting with the light chain, I'm going to have a VL, a constant region, and here I just assign exactly which constant region. So let's do a kappa chain. So you can register any number of different variants of your constant regions with different codon optimized versions and so on. But then we're going to add another single chain. So let's do a linker, a VH, and a VL. Oh, sorry. We're going to need a linker between them too. A VL. We need to assign a specific linker. Like that. And also say that this is going to be our single chain binder. And then for the heavy chain, just a VH in the constant region. We're going to do a IgG1. And all that's left is to just give this some type of isotype. We can call it bispecific and our bispecific template. So I also selected what vectors I want this to go into. So you can choose to work on just the protein level or also the DNA level. But so what I also did is selected a vector backbone that these chains are going to go into. So to then finally put our hits, which was the goal of this, we're going to choose our newly created bispecific template. We're going to for the HVL position of this AB, we're going to use some other. Let's do a 4.1.BB clone. We'll do that. And here we're going to actually copy the list of our hits before, so I have them prepped. Take those 8. We get a little preview. We're going to have 8 new antibodies. With these binders, so the same clone in the mAb position, and then try these as single chain attached to the light chains. And that's it. You can check any one of these out. So we can see this is the antibody. We have 2 different VHVLs. They both have assay data sets, and this one comes from a BALB/c mouse that was immunized with 4.1BB at some point, and this is from the 3rd round of a phage display selection against HER2. We have the chain sequences with all the different regions connected, including the binders, and the targets, the list of the binders, and so on. All right, I need to move on. But that was that. So we started with a fairly simple ELISA data set, and in these couple of minutes here, we selected the hits. We recloned them into a completely new bispecific antibody format.